Researchers estimate the livestock accounts for about 14% of global man-made greenhouse gas emissions. While greenhouse gas emissions from industry and transport are caused by burning of CO2 fossil fuels, agriculture, including livestock, emits most of greenhouse gases in the form of biogenic methane and nitrous oxide. But methane from ruminants is not the same as the greenhouse gases produced by coal and oil. When we burn coal, we add CO2 to the atmosphere, and this CO2 lasts for hundreds of years, and therefore adds to the stock of CO2 already present in the atmosphere. Methane is different. When an animal belches methane, it does not necessarily add to the net atmospheric stock of methane, because methane does not last in the atmosphere for very long. Within a decade, it is converted back into CO2 directly used by photosynthesis to grow new grass, and this process repeats again and again. Whereas with the industry and transport, 100% of emissions add new CO2 to the atmosphere that have been stored underground for millions of years. Conceptually, we can think of the atmospheric stock of CO2 as a bathtub filled with water. The bath is the atmosphere. The water is the CO2 in the atmosphere. The inflow from the tap is the CO2 emissions, and its drain is the limited natural capacity to remove the CO2 from the atmosphere. Before the Industrial Revolution, the inflow equaled the outflow, and the water level was stable, as was the atmospheric CO2 concentration. The Industrial Revolution tipped over the balance by increasing the inflow, therefore making the levels of atmospheric CO2 rise and rise, leading to the current warming of the Earth. In order to stabilize the CO2 in the atmosphere, we need to close the tap, which should require a fast transition to renewables and cutting down on energy consumption. As we already mentioned, methane from ruminants is a different story. Because methane is rapidly reconverted into the cycle as CO2 for plants, we can consider that the water outflow is equal to the inflow. What goes in goes straight out. This will continue to be the case as long as we do not add more ruminants in the years to come. Here we have an example of the evolution for methane emissions from sheep and goats in Europe since 1990. This shows an average reduction of about 3% emissions per year. A new metric from the University of Oxford linking the emissions to warming makes it evident that sheep and goats in Europe have caused no additional warming to the atmosphere. We can stabilize the warming effect of sheep and goats in Europe by having constant methane emissions from now on. Shrinking sheep methane by, for example, 1% annually until 2050 will deliver an even faster cooling effect. This effect contrasts with CO2 from fossil fuels, where similar reductions in emissions would still lead to large warming effects. But it is not all about carbon. The third most important player in this warming story is nitrous oxide. It has over a lifetime of 100 years, and 1 ton of nitrous oxide is considered equivalent to 265 tons of CO2. According to the last IPCC special report on climate change and land, livestock on managed pastures and rangelands accounts for more than a half of total nitrous oxide emissions from agriculture. However, this and other previous nitrous oxide numbers from grazing and manure application may have been overestimated if they use the standard emissions factors from IPCC 2006 inventory guidelines. The most recent IPCC refinement to the inventory guidelines shows that actual nitrous oxide emissions factors from grazing and manure application are at most half of what was previously calculated. A final remark. Currently, many people advocate for getting rid of ruminant livestock as a way to tackle global warming. Grass-fed ruminant livestock currently lives on biodiverse grasslands, but emits large methane emissions, and the more fiber and grass they have in their diet, the more methane they produce, even if their production uses very few fossil fuels. But actually, grass-fed livestock are occupying the space and eating the grass that wild herbivores did in the past. They all occupy the same ecological niche and digest the cellulose from the grasslands. Were they removed, they would then be replaced by other wild herbivores that would produce similar methane emissions as happened in the past. At the same time, new crops would have to be produced to feed livestock to compensate for the loss of grass-fed systems. This livestock on feedlots would produce less methane. However, they more than double their use of fossil fuels and their nitrous oxide emissions from high fertilizer inputs and livestock densities. And they do this at the expense of transforming land and losing biodiversity. The decrease of methane at the expense of increasing fossil fuel use would be of little effect in the short term and would make things even worse for future generations. Humanity, therefore, has to concentrate on curbing fossil fuel use and producing foods with a low fuel footprint.